The idea of a hypothesis is probably not new to you. They come up in a number of classes, from elementary school science to college level statistics. My goal in thinking about them right now is to help you learn about how they can make it easier to understand a research study and the article reporting about that study. The graphics in this slide are two ways to depict the research process. The one on the left is from the online textbook linked in the reading for this topic, and the one on the right is from the first pages of our textbook for class. They're pretty different depictions of the process, but both make two important points. The first point is that research is an ongoing process, and in each iteration, the hypothesis influences the design of the study, analysis of the resulting data, and the conclusions a researcher draws from that analysis. That relates to the second point. The hypothesis not only guides the research, it is also informed by the findings of previous research, so it helps us understand the researcher's focus. That said, we can unpack that idea a little more by thinking about what specifically a hypothesis is. Our textbook differentiates between a hypothesis and a prediction, saying that a hypothesis is more general. It's more common for the specific prediction to be treated as the hypothesis, so I'm going to treat the ideas as if they're the same. From that perspective, we could make the case that the real difference between the three statements and the figure from the textbook is that they each talk about pain in a different way. The original hypothesis just says pain. The first prediction refers to responsiveness to pain, and the third hypothesis refers to tolerance for pain. There are different types of hypotheses, though. We won't come across all of them when we read about studies, but thinking about each of them can help us understand the studies. Statistics refers to alternative hypotheses and null hypotheses. You might remember that the difference is that the alternative hypothesis predicts that there is a difference, and the null hypothesis predicts that there isn't a difference. The alternative hypothesis is also sometimes called the research hypothesis, because when we design a research study, we're typically predicting a difference. That's the hypothesis that authors write about when they're explaining their study, and it's the one that helps us understand the focus. The differences predicted in a research hypothesis can take two forms. If the researcher is predicting a difference because a change in one variable causes a change in another variable, the hypothesis is experimental. If they're predicting that variables are related without indicating one specifically affects the other, the hypothesis is non-experimental. Regardless of the type of relationship a researcher is predicting, the hypothesis can also differ in how specific it is about the predicted difference. A directional hypothesis, also referred to as one-tailed, specifies whether the change we're predicting will result in an increase or a decrease. A non-directional hypothesis simply says there will be a difference. Here are examples of the different types of research hypotheses and the null hypothesis. The variables are the same as we used in the examples in the textbook. When we see hypotheses for actual studies, they are more likely to be directional. Thinking about the different types of hypotheses helps us add two more ways that hypotheses help us understand a study, both of which relate to the more general idea of knowing what to look for in the other parts. Knowing the type of relationship being predicted helps us know what to look for when we're reading about variables and the procedure, both part of the research designs that we're going to learn about. Thinking about the direction of the predicted change helps us understand the findings of the study. For example, if the researchers predicted that swearing was negatively correlated with the experience of pain, in other words, they predicted that the experience of pain decreased as swearing increased, and we were able to determine that the hypothesis was supported, then we understand that someone who's experiencing pain might swear a lot. Mapping the ideas from the previous slides to the chart of the research process from our textbook helps us illustrate how the hypothesis influences most of the research process, and therefore, why identifying and understanding the hypothesis helps us understand the study. Given that, finding the hypothesis can be a helpful way to make sense of a journal article, as well as a good starting point for designing a study.